Hi everybody. We've just started our week 11 and 12 module. So we're going to start with lesson 11a, which is all about exception handling, how to get Python to be a little bit nicer when something goes wrong as you're running a program. In lesson 11b, you'll learn how to grab information off the internet. In lesson 11c, you'll see how that's particularly applied to getting information from the Google Finance website, which is what you're going to use for your programming assignment. So our module for weeks 11 and 12, 3 video lessons, 1 programming assignment. You have 2 weeks to get the programming assignment done. However, your very last module overlaps this one. Your capstone project, your final project to graduate from this course, covers weeks 12, 13, and 14. You will have to be back on the website halfway through this particular module that you're working on right now. So you may not have finished your program for weeks 11 and 12. You will definitely have to be back on the website next Sunday in order to, that'd be Sunday the 19th, I believe, in order to see what the requirements are for your capstone project. So I will definitely talk to you then. Now let's get started with lesson 11a, exception handling, try and except statements. So what are these all about? You've all seen stuff like this when you're running in Python. You've seen red error messages, sometimes that go on for a long time and that are sometimes a little bit hard to read. So sometimes we try to execute a line of Python code which has absolutely correct syntax, but at the time we run it, something goes wrong. For example, maybe we've got x equals 5. That's a perfectly legitimate statement. Then we've got y equals 0. That's a perfectly legitimate statement. Then we've got print x divided by y. That's a perfectly legitimate statement unless you happen to be dividing by 0. What happens if you run this either by typing the lines in the Python shell in idle, or if you have this in a program and you're executing the program? What happens when it gets to the print statement? You get all of this red error message part. And the most important thing to look at is at the very bottom it says, oh, you've got a 0 division error. What happened? It doesn't know what x divided by y is when y equals 0. And your program stops. It will not run anything after that. Well, maybe you'd like to be able to recover from that in your program and say, wow, if that was 0, I'm going to print out, sorry, I can't divide by 0, but keep going. We'll learn how to do that. Here's another type of thing that I know all of you have seen. Let's say you're trying to open a file with this data file equals open, and you give it a file name, and maybe you're opening it for read access, and you type the file name in wrong. Maybe that wasn't the correct name, or it was in a different directory. I know you've all done this one. I know I've done it a zillion times. What happens? Your program stops and you get this file not found error. Maybe we'd like to be able to do something here. Let's see how we can. When you get a runtime error, when you run a program and you're the programmer, well, it's annoying, but that's okay, because you can always go back to your source code and fix the problem and make it work. That's the process of debugging. You do it, I do it, every programmer does it. You run your program, see what goes wrong, fix whatever went wrong. But suppose you're writing a program for somebody else to run. You don't want them ever to see a Python runtime error. Why do they care that there's a traceback and here's the calls and something on line 161 had an error that they don't understand the error message for? They won't understand it, and more importantly, they can't fix it. If you wrote the program, they don't even have access to your source code. So how do we handle runtime errors in advance? That process is called exception handling. And in Python, you do that with the try and the except statements that work together. Some of you may be familiar with other languages like Java, where you use try and catch. Here we use try and except. So let me just go through an example and then we'll break it down line by line. Here's my new keyword, try. It gets a colon, so I have to have an indented block. everything that happens in this indented block just gets run. But if a runtime error happens on any of the statements, here I've just got one statement, then Python looks to see, do you have an exception handler for that type of error? In this case, we've put an except statement, and then we say, what is the exception? And you have to get this typed exactly correctly. The thing that Python would have given you in the last line of its red error messages. We just saw that on the previous page, zero division error. So if I try and do print x divided by y and it works, no problem. Maybe x was 5 and y was 1. It'll print out 5 divided by 1, no error, and it'll skip the except. If, however, y happened to have a value of 0, and I do print x divided by y, that print statement won't work. But I'll no longer get the error message from Python because I've told it I want to handle it here. I say except the name of the error. If that error gets raised when I'm running anything in the try area, then it'll do the code that I've got indented under the except area. In this case, I'm just printing out, oops, you can't divide by 0. So maybe it's a nicer error message, and more importantly, it does not stop the program. So whatever happened after the try statement, maybe you got more statements right here, they will execute instead of your program ending. Okay, here's another example. Suppose we have file name equals bad name dot comma separated variable, and we do a try to open the file for read. We can have an except statement that's looking now not for zero division error, but for file not found error. Remember, that's the one that we saw on those red error messages on the previous page. If that happens, let's print out a nice error message, file name not found, using default file instead, and let's not just print out an error message, let's do something else. Let's open a different file. Let's open the default file. Hey, open this, give me a file name. We're going to try and open it. If that doesn't exist, I'll use the default file. Or maybe you want to ask them again for, hey, this didn't work. Maybe you spelled it wrong. Enter the file name once more. Or maybe you want to put all of this in a loop, and you'll loop through until all of a sudden they've typed it incorrectly. Your choice of what to do inside your exception handlers. So here's the syntax of the try and except statements. Keyword try doesn't take anything with a colon. Whatever is indented here, those statements, that's the main action. Those get run. But if any error occurs when those are run, Python will look at your except statements. You can have one, you can have more than one. You can have as many as you want, and it will check them in order. And whenever it finds one that works, oh, this, let's see, zero division error happened. If your first one was handling something other than zero division, it'll skip that. Maybe the next one had zero division. It'll run whatever's in that except. Once it runs an except, it won't run any more excepts. So the first one it finds that matches, it'll go through. And you can do it like we did in the examples on the previous page, except the name of the exception. Or you can do except and create a tuple. Remember, a tuple is a grouping of items that you put inside parentheses. And you can put 2 exceptions in there, or 3 exceptions, or 4 exceptions. If there were 3 or 4 things that you wanted to handle the exact same way, instead of having 3 or 4 except statements, you could put them all in one. You can have an except statement that doesn't have any exception. You notice this was except with a name, except with maybe more than one name. If you just have except without anything, then any runtime error will go here. Most Python programmers believe this is not very good style, although it's perfectly legal to do it in Python. It's not very good style because you should be trying to handle things explicitly that you know can go wrong instead of just anything in the world. However, sometimes it's useful to have that in there. Then you could have an else statement at the end. The else statement is something that gets run after the try if none of the excepts happened. I've never used an else with a try in Python, but there are occasions where that might be what you want to do. Run the try. If something goes wrong, you'll either do this, this, or this. If you didn't do any of those after the try, you'll do the else. Okay? You might want to refer back to this as you write your programs this week. Now, sometimes you know what error will be raised because you've seen it happen to you before. Sometimes you have to anticipate what might go wrong. You don't run your code and have it blow up. You run your code and you say, you know, this could be something, somebody could type in the name of the file wrong. And so you handle that exception. Now, what are the exceptions? There are a lot of them. A list of exceptions can be found in the Python docs. Remember, you can get to the Python docs by going into help in idle, or you can go on the web and just search for Python docs. Look for the section that's called built-in exceptions. And if you're doing it from idle's Python docs under the help, you'll see that in the Python Standard Library section 5. But if you just search for built-in exceptions, you'll get a list of more than you ever wanted to know. Here's the ones you're most likely to see. Index error, I'll bet you all have seen that one, is an index is out of range on a list or a tuple or a string or another sequential object. In other words, you tried to use square bracket 17 of something that only went up through square bracket 16. Key error. If you've ever worked with dictionaries, you've probably seen this. Suppose you had let's say you have something called My Dictionary, and you try and reference the name key, and you don't have a name key in it. Then the Python program will raise a key error. It'll blow up, and your program will stop running unless you handle key error. File not found error, real common one. The operating system can't find the file you're trying to open. End of file error, EOF error, trying to read a file after you've already exhausted its contents. You might be able to see how this could be useful when you were, say, trying to pull pickles out of a file and you didn't know how many there would be. So you kept doing it until you got an error. Maybe now you could keep doing it until you handle the error. And then just exception. This is the general purpose error. It matches every error that could be raised. It's generally poor practice to try and handle this one. You should handle the specific errors instead.